Hi class, this is section 4.1. We're starting chapter 4 here, and it's all about quadratic. So 4.1 is graphing quadratic functions in standard form. So a quadratic function is a function whose equation in standard form is y equals ax squared plus bx plus c, where a is not equal to 0, because if a was 0, that x squared would go away. The graph of a quadratic function is a parabola. The lowest point is called the minimum, or the highest point is called the maximum. It'll have either a minimum or a maximum, but it will not have both. So when a is greater than 0, our parabola opens up. So it'll look like this. When a is less than 0, it's going to open down. So it'll look like this. So just by looking at this parabola right here, this is a parabola. It's got a minimum right here. It opens up. So we know that a in the equation must be positive in order for it to open up like this. The axis of symmetry passes through the vertex and has the equation of x equals the opposite of b over 2a. That's our equation for the axis of symmetry. So for this graph right here, our axis of symmetry would go right through here, our vertex, and it's also called our minimum. But our axis of symmetry would be this line right here. And if I draw that in, this would be my axis of symmetry. And what that tells us is these two sides of the graph look the same. It's like a line of reflection. So the minimum is actually our vertex. So I want to add words here, minimum or maximum. Another word for that point is the vertex. So let's talk about parent functions. A parent function for quadratic is the most basic function, y equals x squared. That's our most basic quadratic. So let's make a table and graph it. So I'm going to use, it's our most basic, so it's right around the middle, so I know to use -2, -1, 0, 1, and 2. And if I plug -2 in and square it, I get +4. -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So I'm going to put my points on here. 0, 0 is my middle point. I've got -1, 1, and +1, 1. And I've got -2, 4. And +2, 4. And parabolas aren't real easy to draw. They're not going to be perfect, but try to do the best that you can, and I will try to do the best that I can. There's my parabola. So my vertex is right here. That's at the very bottom. It's a minimum, and it's the point 0, 0. For your parent function, the vertex is always 0, 0. The axis of symmetry, I'm going to draw that in here. It goes right through the middle. So my axis of symmetry is this line right here through the middle. And that's the line x equals, well, all the x values on that line are 0. So our axis of symmetry is x equals 0. I'm going to pull this up so that we can see these words right here. It says, for each function, you'll be asked to identify the vertex and the axis of symmetry. So get used to naming those, okay? And again, this is a minimum. It's my vertex. And this line is my axis of symmetry. And we write the equations like this. X equals, and then you write the x value that it goes through. So let's do a couple of graphs here. So for this first problem, it says graph y equals 1/4 times the quantity x squared. So my axis of symmetry, I'm going to do this first, okay? Do first. And here's my formula. It's x equals the opposite of b over 2a. So in standard form, this is ax squared plus bx plus c. So my b value would be right here, what's next to the x, and there's no x term, so we know b is 0. So the opposite of 0, no, that's just 0, over 2 times a, And my a is right here in front of the x squared. That's 1/4. So 2 times 1/4. Well, we have 0 over a number, and 0 over anything is 0. So my axis is going to be x equals 0. So let me draw my axis of symmetry. X equals 0 is this line right here. It's really my y-axis. I want you to get into the habit of saying x equals a number, and this is x equals 0. So because we know our maximum or minimum has to be right there on the axis of symmetry, we know for our vertex the x value is 0. So to find the y value, we just plug it into our equation. Y equals 1/4 times 0 squared. And 0 squared is 0 times 1/4 is 0. So 0, 0 is my vertex. So my vertex is going to go right here. Now just looking at the a, I know it's positive 1/4, so I can anticipate that my graph opens up somehow like this. Let's just make a little table, and remember how both sides were reflections? So I can just do 2 points. I could do x value of 1 and x value of 2, and then reflect them over. So I'm going to do a table, xy, and I'm going to use an x value of 1 and an x value of 2. So for this one right here, I'm going to do 1/4 times 1 squared. Well, 1 squared is 1 times a fourth is 1/4. So 1/4 is about right here. That's 1 point. And I know I can reflect it over the axis of symmetry, and it's going to come right over here to be the other point. And then if I plug 2 in, that's 1/4 times 2 squared. Well, 2 squared is 4. 4 times 1/4 is just 1. So I got the point 2, 1, which is right here. And if I reflect that, it's 2 away from the axis of symmetry, so 2 in the other direction would be right here. So this is my parabola. It looks like this. Now, the next question says, describe the transformation. A transformation is a movement or a change. So how did this change from my parent function up here? Okay, and if you notice, our vertex is in the same spot, so it did not move up or down at all. But this point right here and this point right here, they would be right here and right here on this graph. They kind of slid down to 1/4. They slid on down to 1/4. So it went from 1, 1 over to 1, 1/4. So because this slid down, we call that a shrink. And it moved down to 1/4, so we call it a shrink of 1/4. Because we look at where those points moved. It didn't move up or down. If it did, we would have to write that as well, but it didn't, so we're not going to write that. Let's look at the second graph here. It says graph y equals 5x squared plus 2x. So remember, we're going to do first the axis of symmetry. So it's y equals the opposite of b over 2a. And my b, if you remember here, b is what's in front of the x. There's no just plain x here, so b is 0. My a is the number in front of the x squared, and that's 5 right here. So we know that b is 0. So it's the opposite of 0 over 2 times 5. Well, that's 0 over 10, which is just 0. So my axis of symmetry is x. It should be x, not y. X equals 0. There's my axis of symmetry, and I'm going to draw it on my graph. Here's my axis of symmetry, x equals 0. Okay, so now I need to find my vertex. I know it's on the axis of symmetry, so the x value is 0. To find y, we plug it into our equation. So y equals 5 times 0 squared plus 2. 0 squared is 0 times 5 is 0. 0 plus 2 is 2. So my vertex is 0, 2, which is right up here. There's my vertex. Okay, so I know that's my vertex. And already looking at this, if my parent function is here at 0, 0, this graph moved up 2. Okay, so we have to say, for our describe our transformation, we can say it moved up 2. Now we need to find more points, so again I'm going to use the point, try and find points in this direction. You could do this way and then reflect them over. Either way, I'm going to find values for 1 and 2 though. So let me make my table. Find a value for 1 and a value for 2. So for 1, it's 5 times 1 squared plus 2. 1 squared is 1 times 5 is 5. 5 plus 2 is 7. For 2, so I got the point 1, 7. So 1, that would be right about up here. And then if I reflected, it'd be right about here. So if I do 2, I know that's going to be a whole lot further up. So I don't have to worry about 2 because it's not going to be on I'm not going to be able to put it on my graph. So there's one side of my parabola. Again, I'm going to do it as nice as I can, but I can't get it quite perfect. So that's what my parabola would look like. It moved up 2. But notice on my parent function again, if I go over 1, I go up 1 to get to another point. Here, if I go over 1, I have to go up 1, 2, 3, 4, 5 to get back on to this point. So if I go over 1, I go up 5. So on this problem, because if we went over 1 and up 1, then we move down to get here. That was a shrink. Here, if I go over 1, I have to go up 5, so we call that a stretch of 5, how many it moved up. Okay, so it moved up 2, and then we had a stretch of 5. Let's look at the other side of your notes. Okay, so here are some notes for you on a couple important things. First of all, it's finding the vertex by hand, which we just did, okay? We did these. To find the x value of the vertex, use this formula. We did that on the previous side. To find the y value of the vertex, substitute the x value into the equation and find y. We did that on the previous side. And then the final answer of your vertex is a point. So we did that on the other side here. This next part here, though, says finding the vertex on your calculator. So this one is where your graphing calculator will do the work for you. So you should take a moment, plug these into your calculator, go through and follow that, and make sure for the 2 problems on the previous page you get the correct vertex. So this is a hint, a graphing calculator hint for you. So make sure you go through and do that so that you can use your graphing calculator. That's why you have it. Let's do the next example. It says find the vertex of y equals 2x squared minus 3x plus 6 by hand, and then check with your graphing calculator. So I'm going to do the by hand part, and I want you to make sure you go back into your calculator and check it with your calculator. So the first step is find the x value using this formula. So here's our a, here's our b, and here's our c. So b is negative 3. So the opposite of negative 3 is positive 3 over 2 times a is 2. So this is 3 over 4. That's the x value of my vertex. So I know for step 3, the x value is 3/4. We just have to find the y value now. So for step 2, we're going to plug our y value, or plug our x value into our equation. So y equals 2 times 3/4 squared minus 3 times 3/4 plus 6. So y equals, plug that all into your calculator and you'll get 4 7/8. So it's 3, 4 and 3/4, 4 7/8. So I want you to make sure, this is the correct answer, I know that. I want you to go through your calculator and follow these directions and make sure you can get the same vertex. Now they may have this in decimal form, which is perfectly fine, but make sure you can get the same vertex using your graphing calculator, because you should be able to know how to do it on your graphing calculator. It just makes things go a lot quicker. So here are a couple more examples. Let's do one of these. Now one thing I noticed right away is this a value is negative. So since that a value is negative, my graph's going to open down like this. And that's from my experience working with these. And it's something you should get used to seeing. So I want to graph this value. First I'm going to find the vertex. Okay, actually first I'm going to find the axis of symmetry. I think that's easier to do first. So my axis of symmetry is x equals the opposite of b over 2a. So A is right here, B is right here, C is right here. B is positive 4, so the opposite of B is negative 4, over 2 times A. Well, there's no number here, but I could put a 1 in, so it's 2 times negative 1. So that's negative 4 divided by negative 2, which is positive 2. So my axis is x equals 2. So let's draw that in there. X equals 2 is right here. Now, didn't our axis of symmetry move to the right 2? So x equals 2. So it moved to the right 2. So what you have to keep in mind is when you make a table of values to graph this, you're going to use different numbers because our whole graph moved to the right 2. But let's finish finding our vertex. We know for our vertex the x value is 2. Let's find the y value. So to find the y value, we're going to say y equals the opposite of 2 squared. Notice I did not put parentheses in there. You don't want parentheses. So plus 4 times 2 minus 3. And if you put that into your calculator just like that, you'll get the value of 1. So over 2 up 1. This is our vertex. So our graph not only moved to the right 2, but it also moved up 1. Okay, so we've got our axis of symmetry. We've got our vertex. Let me just highlight those. Here's our axis. Here's our vertex. Next, it says identify the y-intercept. So I'm going to give you a hint here. My hint for you is it's C. C is always your y-intercept, okay? Because when you put 0 in for x, well, the x squared is going to be 0, the 4x is going to be 0, and you're left over with just your C. So your y-intercept is always C. So it's C. So I'm going to have the point 0, comma, negative 3, because it's 0, comma, C. So 0, negative 3 would be right down here. And yeah, look, that's making our graph open downward, which is what we want. Now remember, I can reflect this point. So this is 2 from the middle. So if I go 2 in the other direction, I'm going to have a point right there. So right here's another point. Now I'm kind of missing values in the middle here. Okay? So I'm going to use the smaller number, and then smaller x value of 1, to find another point that's in here and another point that's in here. So I'll find 1 for x equals 1 and then just reflect it over. So if I let x equal 1, I'm just doing this so I can find a better graph. So y equals the opposite of 1 squared plus 4 times 1 minus 3. So when x equals 1, if you simplify that, you get 0. So I've got the point 1, 0, and that's also on my graph. So 1, 0 is right here, and if I reflect it, it's right here. So I'm going to draw my graph in. So there's my graph. The next part, state the maximum or minimum value, and I've already told you it's the vertex. Always. It's always the vertex. So right here is my maximum, because it's at the top. It's a maximum. And it's this value right here. So let's say that. It's 2, 1. And it's a maximum. Okay, let's do this last problem together. I'm going to do this with you just because I know this is new and I think it's probably more helpful to see as many possible problems as you can. So I'm going to just pick a different color here. So we're going to graph y equals x squared minus 3x plus 3. Remember, I like to find the axis first. So to find that, I use x equals the opposite of b over 2a. So b is negative 3. The opposite of b would be positive 3 over 2 times a is 1. So that's 3 halves. So my axis is x equals 3 halves. And 3 halves is the same as 1.5. So I know my axis of symmetry is going to be right down right here through 1.5. So that's x equals 3/2. So there's the middle of my graph. My vertex, I know is going to have an x value of 3/2 because it's on that axis of symmetry. So to find your y value, you plug it in here. So we do y equals 3/2 squared minus 3 times 3/2 plus 3. And if you simplify that, you get 3/4. So my vertex is 3/2, comma 3/4. And let's graph that. Over 3/2 up 3/4 would be right about there. Okay. Next part, identify the y-intercept. And remember, my hint was it's C. So C is positive 3, so my y-intercept is the point 0, 3. So I'm going to put 0, 3 on here, which is right here. And then I'm going to reflect it to find another point. See, that's 1.5 away, so 1.5 away would be right there. So I got another point right here. Now, again, I've got this gap between these points right here, so I'm going to find this value when x equals 1. I'm going to find what y is to find one more ordered pair. You're not always going to use x equal 1. It just works out for both of these ones. So when x equals 1, we can say y equals 1 squared minus 3 times 1 plus 3. So that equals 1. It equals 1. So I've got the ordered pair 1, 1. So 1, 1 is right here. And if I reflect that, I've got this point right here. So I'm going to draw my graphing. It looks just like this. The last part here, state the maximum or minimum. Well, it's right here, and it's at the very bottom, so it's a minimum. Okay, so, and it's our vertex. So it's 3/2, 3/4, and it's a minimum. Okay, so I know this is quite a bit, kind of new to you. You really did see it in Algebra 1. You may not remember it so well. But make sure if you have any questions, you start it so that we can talk about in class tomorrow. And have a great night.